Okay, in this video we'll talk about electric forces and the electric field. But first of all, we need first to understand what electric charges are. Okay, so before we continue, we need first to know what an atom is. Okay, so let me just draw. If I have this, we know that inside the atom we are going to have protons and even neutrons. Okay, so here they are. Here I'll have two protons there. Again, I'll have two neutrons there. Then we also know that around the atom there is what we call electrons. Okay, so we can say that this is a proton and this is an electron. We also know that this is just basically a neutron. Okay, so what we need to understand, guys, is this. We know that protons are what? We know that protons are positive charged. So we can say protons are positively charged. Then we also know that electrons are negative charged. Then neutrons are what? They are just neutral. They don't have any charge. Okay, so now apart from that, what we need to understand again is what we are going to be looking at basically is an atom. So upon knowing that, then we can go to what? To electric forces, because these atoms, they are the ones which they are going to help us to know, to say like charges they repel and like charges they attract. So we need first to understand the basic concept of an atom. We need to understand that around the atom or around the nucleus there is what we call electrons, and electron is a negative charge. Okay, then from there again we can talk over. Let me first erase this. So that we talk over another issue, which is okay, let me just use this. So apart from that, we can talk over another issue, which is electric forces. Okay, electric forces. So what are these electric forces? You know, immediately when you understand this concept, it's going to be easy for you to answer any question concerning electric forces and electric field. Okay, so what we need to understand is we need to understand that like charges repel and unlike charges attract. So I'll just draw here. I'll have two charges, then I'll have the like charges. I'll have positive there, I'll have positive there. If you are trying to bring these two charges together, what you are going to discover is they are going to repel each other. Okay, so you're going to have the force in that direction. They are going to repel each other. As a result, these two guys cannot come together. So the principle here is like charges repel. Then what if we talk over unlike charges? How can they do? Okay, so if I have two charges here, let's say these two charges are what? They are unlike charges. Or let me use the same thing. So we're going to discover to say these two guys, they're going to attract each other. Okay, so we're going to have the force in that direction. So these two guys are going to attract each other. Okay, so from there, upon knowing to say the like charges they repel, the like charges repel and like charges attract, then we can also come, because we can have an object or we can have a material which is not it doesn't have any charge. The material is too neutral. Now we can make that material to be charged. Okay, so how can you charge a material? That's what we want to do. So here we come. Let me just erase this. Okay, so we can do charging materials. Okay, charging material. How can you charge a material? So basically we have only two methods which we can use to charge a material. The first method is the charging by a conduction. Charging by conduction. Okay, so how can you charge a material by conduction? Here is the method. So when you hear the word conduction, we know to say two materials or two objects have to be in contact. Okay, so if I have two here, if I have an object, if I have my object there, okay, so let me say I have my object here, or let me say I've got a material here, and this material, or let me use different color. Let me use different color. I have a material and I have another material, so I'll say I have material A and material B. Okay, so I have material A and material B, and we know that inside there, let's say maybe this is positive charged. Okay, then we have a neutral atom that side. We have neutral atom. So now when we say this atom is neutral, we just mean to say the number of electron is equal to the number of protons. Okay, meaning that material is what? Is neutral. So here I have also how many electrons? I have 4 protons, then I need to have again 4 electrons. Okay, so this guy is neutral, and I have this guy is positive charged. Okay, so now if I bring these two guys together, what will happen? Okay, so let me first erase the top part. I move that on top, or I say, yeah, let me just do that. Let me just do this. Okay, okay, let me erase that. Then what I want to do is I want to put these two guys, they have to be on top. Okay, so we just put those two guys on top. Okay, so we have them there. What can we do now? What we want to do is we said we have equal number of what? Equal number of let me use the white color. We have equal number of electrons. So we have positive there. We have 4, and we need to have again 4 there. Now if I try to bring these two guys together, they have to be in contact. Okay, these two guys, they have to be in contact. So if these two guys are in contact, this is what is going to be observed. We know that here we have a lot of protons. Now when we say an object is positively charged, we doesn't mean to say there are no electrons there, but electrons are there, but the number of protons are more than the number of electrons. So the positive ones are more than the negative ones. That's why we are saying the material is positive charged. Okay, so we are going to come here and say we have the positive here, we have the positive, then here we had what? We had negative and positive. But what will happen here is this. Since we are saying like charges repel, then unlike charges attract, what will happen here, guys, is this: the electron part, the negative guys will come closer to what? To the positive ones. So they will line themselves there. There are 4. So they'll come there. Then the positive ones, instead of them coming to A, we say this is A, this is B. Instead of them coming to A, they'll start running away. Then they'll be here. Since we are saying like charges do what? Repel. So this is what will happen. Then what will happen there now is, since we have a lot of number of protons in A than in B, therefore the protons, they'll start moving now. The positive charges will start moving from point A to point B. As a result, as a result, we are increasing the number of protons, or we are increasing the positive charges in B. Okay. So as we are increasing the number of protons in B, then you are going to discover to say we are going to have a lot of positive charge in B than in A again. Then what will happen here is this. Okay, this is what will happen. So these guys will start now moving, going there. So we have a lot of protons that side in B. Then in B, that means that if these guys are migrating from point A to B, we are going to have a lot of protons, or we are going to have a lot of positive than negative in B. Therefore, if we have got a lot of positive, meaning the material is going to be positive now, then we are going to have this. This is what we are going to have. This is A, and we are saying this is B. So what we have is this. This is what we are going to get. Here, instead of having, now we are going to have only maybe 4. About 4 protons, because some of the positive charge, they have gone to B. Then here we are going to have a lot of protons. Therefore, we are going to have this material, and this material is going to be now charged from neutral to positive charged. So this is how we can charge a material by conduction, meaning you put them in contact, you are going to see the like charges repel, the unlike charges they are going to attract. As a result, those other charges, they are going to start moving from that particular point, from point A to B. As a result, we are increasing the number of protons in B. Then you are going to have a lot of protons in B. Therefore, the material is going to be positive charged. Now we have another type of charging, which is what we are saying charging by induction. So how can you charge a material by induction? So let me just erase this. Okay, let me just erase this. Okay, so how can we charge a material by conduction? Okay, charging material charging a material by induction. So here there is no need of contact. Okay, there is no need of contact. What is happening here is we are going to have the same things. We are going to have A, then we are going to have another one. You can use that color. We say you have this. You can say you have A and B. So what will happen inside there? We are going to have the what? Let's say this is positive charge, meaning we have got a lot of positive ones. Then that side we are going to have positive and negative. Okay, so that is what we have. Now this is neutral, this is positive charged, this is neutral. Okay, so now how can we charge by induction? We don't have to contact these guys, but we need just to bring them as the concept which you are supposed to use here is this. You bring them together, but you don't have necessarily to contact them. Okay, then what will happen is as A and B, they are coming close together, you are going to discover to say like charges attract and like charges repel. So what will happen there is this is what will happen. We have our A and we have our B. So we have our B. So let me bring this one close to to this guy. I can use another color. Okay, so this is what will happen. This is what will happen. So this is what will happen here. What will happen is this is what will happen. Okay, so what will happen there is, we know that like charges repel and unlike charges attract. So we know that in A we have protons, or we have positive charge, we have positive ones. Then in B we have both positive and negative. So what will happen then when we want to charge this material? This is what will happen. Here we have the positive ones, the way we had there in A. So this is A. Okay, so here what will happen here is, since like charges repel, the positive ones, they will go far away. Then the negative ones will go now near to what? The negative ones will come there. Okay, this is what will happen. Therefore, if we want to charge a material by induction, we are supposed to connect now. From here now, we connect a wire or this material. So we are going to assume that this is our F. So we connect there. So what will happen is, since this is our B, since this is intact by this one, when we connect the wire there, all the protons are going to be removed and they are going to be thrown away to the earth. Okay, as a result, what we'll have there is this. Let me first erase this. This is what we are going to have. Okay, so they are going to be thrown away there. Then we are going to remain with only positive ones there. So here we had positive. We say this is our A, and we had B. We had the B there. So since those guys are going to go there, then we are going to have only negative. Yeah, meaning this is now positive and this is negative, and we have charged this material by using what? We have charged this material by using what? By using what we call induction. Okay, so those are the two methods which we can use to charge a material. Okay, so from there then we can talk of something else. So what are we going to do next? So upon looking at that, we can also do something else very important. Let me just lap the board. Can do very important thing. So now what we are supposed to do is the Coulomb's law. Okay, so we want to see what is happening under Coulomb's law. Okay, so before I explain what is happening under Coulomb's law, we said we are talking about electric forces, okay, and the electric charges. So we said, if you can remember very well, we said if we have like charges, or let me use unlike charges, we say maybe we have another one is positive, another one is negative. We said these two guys are going to attract each other. So these are the electric forces we are talking about. Okay, so these are the electric forces we are talking about. Okay, so now what we need to understand is what we are going to have. We are going to have these are the electric charges. So let me say this is Q1, this is Q2. That is electric charge 1, electric charge 2. So as we are trying to bring these two guys together, we know that they are going to attract each other. The reason why they are going to attract each other is these two guys, they have opposite charges. Okay, and as these guys, they are going to go close to each other, we are going to experience a distance here. Okay, we're going to experience a distance, and we can call this distance as the R. Okay, so according to Coulomb's rule, we are saying the electric forces, let me use another different color. We are saying the electric force is equal to K Q1 times Q2. So these two guys, Q and in short, the electric charges, they have to be in modulus because we are getting the absolute values over R squared. So where so this is what happens where here we have R squared. So K is basically Coulomb's constant. K is just Coulomb's constant. K is Coulomb's constant. Coulomb's constant. Okay. Then we also have what we call R. So R is just basically the distance between two charges. Okay, so that is what we need to understand. Now let's discuss something here. If we can see here, guys, if we can see, let me just remove this. If we can see something here, okay, if we can see R, let's start with K. We start with K. So K is just a constant. So K is just basically 9 times 10 to the power 9 coulombs meter squared per coulomb squared. That is our K. Okay. So now another thing what we need to understand is since electric forces and electric charges, they are inverse proportion to each other, then we can come with the conclusion to say as the electric forces increases, the electric charge has to increase. So in short, when we increase the electric charges, the electric force is going to be increased. What if we talk of R? So we know that R is on the denominator there. As we increase R, the electric forces, they have to reduce. They have to reduce. Okay, so we can come up with the conclusion to say electric charges, they are directly proportional to electric forces, and the distance between two charges is inverse proportional to electric forces. Okay, so now how can we calculate some questions if we have been given questions? Now let's talk a bit of K. We need to understand what K is. Okay, so let's talk a bit over K. So we need to understand that we can say okay, let me not confuse you, let's just leave it here. We are going to be using this, the value of K, for us to calculate the electric field. What if we have different, sometimes you can have like charges. So what will happen there? If I have like charges, this is what will happen. These two guys, they are going to express a force going in that direction. Even this one going to express a force going in that direction. So still we are going to experience a distance. This distance here is what we are going to call it R. So still you can calculate the electric field using the same formula. You come there, you say the modulus Q1 Q2 over R squared. The same thing. That's how we can calculate the what? The electric forces. Okay. So let's do one example. Let's do one example. Let's do one example. We see how we can do it. Let's do one example. One example. So let's say we have two. We have let's say we have like charges. Okay, let's say we have positive and negative there. Positive and negative. We know that we are going to express a force. She's going in that direction, so then we're going to have that. So we say we have Q2 and we have Q1. Okay, we're going to experience a distance from here to there. That's what we're going to call, let's say our R is 2 meters and our Q1 is maybe 5, we say 5 coulomb. Okay, and we say this one is maybe 6 coulomb. Okay, now how can we calculate the electric forces? We have our formula. We said our electric forces is equal to K, the modulus, say the modulus of Q1 Q2 over R squared. So we have our K is 9 times 10 to the power 9. Okay, then we have another one which is 6 times 5, and we have our R as 2. Now we have to square it. So what do we get? I get my calculator here. I have 6 times 5 times 9 exponent 9 divide 2 squared. I'm getting 6.7 6.75 times 10 to the power 10 newtons. So this is the force which we are going to experience there in that example. Okay, now from there, what else can we talk about? We can also talk about superposition principle. And how would we do that? Okay, how would we do that? Okay, so let me first erase this. Okay, we can talk of superposition principle. What can we say about this? Okay, so superposition principle, we need just to understand that when more than one charge act on a charge of interest, each exert an electric force. What do we mean when we say that? Now here we know that we can have more than 2 electric charges. Okay, we can have more than electric charges. So let's say maybe we have 2. We have this one, we have our, so I'll say we have 3, and we have another one in the middle there. So let's say these are negative, then that is a positive one. That is a positive one. So what will happen there? We know that this is going to be attracted by the negative. Even this one is going to be attracted by the negative. Okay, so we are going to experience 2 electric forces, another one going to the left, another one going to the right, because we have got three charges there. Okay, so what can we say? We can conclude to say, if this is our negative charge, this is our positive electric charge, this is our negative electric charge. And how do we do that? Okay, so here we know that we are going to experience a distance there in the middle. There we're going to cover a certain distance, so you can say this is R1, this is R2. Okay, so we can calculate these separately. First of all, we can get the electric charge, we can calculate the electric forces of okay, just a minute, let me include this one. Is supposed to be 1, 2, then this one 3. We can calculate the electric forces of 1 and 2. Then after that, we are going also to calculate the another force of 2 and 3. After that, so we can denote this one as our force 1, this one as our force 2. After finding that, then we can come up with the conclusion to say F1 or the F net is equal to the F2 minus the F1. Now, why am I using minus there? We are getting the concept from vectors. If I see to say my F1 was going negative side, meaning I can conclude to say that is going to negative side, but our goal is to get the net electric force. How can you do that? Now let's go back to this diagram. If we go back to this diagram, we are going to see to say the electric charge for this one, or let me say the electric charge for Q1 is not going to be the same as Q3. So if Q1 is greater than Q3, then we know to say the positive one is going to go where there is more electric charges. So here, this example, I'm just giving you to say my Q1 was less than my Q3. Okay, but in either direction you can take it. So that is the principle of superposition. Now, what if we have these two electric charges in different direction? How can we do that? Okay, now the concept which I want to bring in is this. This is the concept which I want to bring in. Okay, this is the concept which I want to bring in now. What if we have two guys? Let's say we have this, we have that, and we have that. Okay, my drawing are not accurate, so what do we say about that? Or let's say this is negative, this is negative, this is positive, and this is negative. We know that this one is going to be attracted there. This one is going to be attracted by that force. So we can say, yeah, this one is going to be attracted by that force. This one is going to be attracted by that force. So where is going to be our net? Our net electric force. So what's going to happen there is, since we are considering this as a vector, then we can see that our net electric field is going to be in that direction. So that will be our net electric field. It will go in that direction. But you can also calculate the electric force or electric forces using the same concept which we have just done. Okay, I don't think you have any question there. Okay, so